colleague. I'm very glad to be here. Thank you so much for the organizing committee for this invitation, the possibility to be here in this beautiful place. I would like to discuss, I would like to discuss one of the possible methods of solving of very heavy, very hard problem of LENR that may be realized in a very simple usual laboratory. Oh. What is not connected? Oh. Oh, terrible. Please help me. I don't know why.
No,
Okay. So the traditional experiments on low-energy nuclear reaction are typically conducted within a solid-state matter matrix loaded with hydrogen isotopes. In such closed system, it is challenging to perform a realistic analysis of processes in such a system. More apparent, the nuclear processes that occur during traditional external experiment using the standard accelerating technique. This method required a system for the accelerating particle to high energy, unfortunately. And so the efficiency of such method is very low, no more than 3–5%, due to the very strong interaction of accelerated particle with atomic electrons. My report demonstrated that the combination of these two methods offers a simple natural solution for realization of low energy system. Let's consider this problem. Very briefly, traditional point of view on the fusion. Yes, the problem of standard nuclear fusion low energy is what is the main problem? Main problem, it is a very low probability of tunneling effect. Of course, it's described by such expression. Very simple, yes, and such because very high magnitude of potential barrier, so the probability is very low. For example, for standard thermonuclear fusion, most simple reaction D plus D at room temperature is probability 10 power minus several thousand, so on. For lithium plus proton, no, approximately the same, very small value. It is not taking into attention the problem of screening, of course. Okay, nuclear fusion at low energy and the present of screening, of course. It is much more better. It is, in this case, it's possible to introduce the screening energy at equivalent the squeezing of potential barrier, or increasing of energy of particles. But also at room temperature, such reaction, the probability is about 10 power minus 18. And for example, reaction, very interesting, lithium plus proton, I will be discussing such reactor more later. The probability also is very small. Okay, let's consider that standard accelerated fusion. Usual accelerated fusion, we have the energy particles accelerated to high energy, for example, 25 keV, for example. If we have the current of particles about 1 milliampere, so it is easy to calculate using standard expression that the generation velocity of intensity of generated reactor is about 10 power 7 count per second. Using by a cross section, very simple values. Okay. If we have the reaction for the same current of accelerating particle, but the low energy, for example, 500 electron volts, the particle release is 10 power minus 31 count per second. It is a factor of 0. Yes, standard point of view. Let's consider expected spectrum of reaction at any point of view of this problem. Let's consider expected spectrum of reaction produced in accelerated lithium plus proton fusion. It is very interesting isotope. Lithium consists of two isotopes, lithium-6 and lithium-7, of course, about 8% and 94%. And also in first reaction, it is the creation of two alpha particle heli-3 and heli-4, and two alpha particle heli-4 with different energies, energy different. So if we can using the standard description of reaction, or calculation the efficiency of reaction fusion, this concentration of one particle is another particle, and averaged product of cross-section and velocity we have. And using the standard calculation for this parameter using astrophysical factor, for such S factor is well known. So for one reaction, Li-6 plus proton, it's about such value. And this temperature in the unit 10 power 9 Kelvin degree. And this, you see, about 50 times less efficiency for reactive Li pair. So what we need expected during such experiment? Probability such reactor great about 50 times, but the concentration of such isotope less by approximately 10 times. So expected spectrum approximately the same. You need some more intensive generation alpha particle with such energy, about 5 times. And such particles. It is expected reaction. Okay, let's consider the realistic experiment. Experiments were conducted, different experiments in these particles. This reaction, experiments very simple. Different geometry of such experiment. For example, proton gun, lithium target, one. Or proton gun and fragment of lithium nanonuclear warhead. Or glow discharge. Approximately the same. Also, in this experiment, we investigated dependence of efficiency of such fusion. First one from the energy particle, because most interesting area it is several hundreds electron volt, not keV electron volt, and also spectrum of generated particle. So let's consider the result experiment. Very, very strange. So once more. Two-kind experiment, expected spectrum, and what is the experimental results? First one, the local maximum of particle release was at an energy about 500 electron volts, 500. And also decrease, and also very slowly increase, of course, to standard value at about 30, 50 kilo electron volts, but it's very intensive peak. And also much more, also much more, but the same interesting, another point of view. It is the expected spectrum, and it is a realistic spectrum. We have very intensive peak of alpha particle helium-4, and absolutely absent helium-3 and helium-4 with such energy. No, zero. Fantastic. 500 electron volts, it is very low in energy. And where is such two kinds of reaction? Heli-3 and Heli-4 with such energy, 1.7 MeV and 2.3 MeV is absent. Very strange result in such experiment. These experiments were conducted many times. It's well published. One can see this result in literature. Okay. There are two main questions to understand this experiment. First one, why the maximum of lithium plus proton reaction is at low energy, about 500 electron volt? One. Why in alpha spectrum reaction there are no alpha particles with energy Heli-3 and Heli-4 with energy about 1.7, 2.5 MeV? Where? What? Why is absent? Similar fundamental problem occurs in the analysis of any other LENR experiment involving particles with low energy. First of all, abnormal high probability of any LENR reaction. Second one, selectivity of nuclear reaction, because according to traditional calculation, the probability of both reactions approximately the same. But one reaction is absolutely impossible, because the same nucleus, the same charge, the same potential barrier, all the same. But this reaction is absent. And also, total absence of radioactive daughter isotopes in any LENR reaction, and very strong suppression of gamma radiation. It is well known. Gamma radiation suppression by 100 times, and practically is absent radioactive daughter isotopes in any LENR reaction. It's very, very fundamental properties, abnormal properties. According to our analysis, of course, it's our point of view, but we have investigated detail. these processes are fully justified in the self-similar formation of coherent correlated state of interacting particles during adaptive, not average, channeling or motion of particles in crystal or quasi-crystals. Let's consider very briefly the base of coherent correlated states. The traditional approach, the physical charge particle tunneling, is based on the assumption of mutual independence of a particle they corresponding to each energy level quantum state. So traditionally, if we have any potential barrier, we have the system of levels. There is in quantum mechanics superposition and mixed superposition at a combination of state that is some fixed phase relation. And mixed, it is no any special phase relation. The conceptual basis of the tunneling effect is connected with wave-particle duality and Heisenberg-Robertson uncertainty relation. Heisenberg-Robertson, the first, was proposed in 1927. Very nice, is the product of dispersion of any value, A and B, is connected with such a relation. From this formula, it is easy to obtain traditional uncertainty relation. For example, product of fluctuation of coordinate, pulse, or energy and time, so on. Very simple result. But this result is related to the not coherent state. If there is absent phase, fixed phase relation between the different agents and functions. This, for example, if we're using this traditional Heisenberg relation, it is possible to calculate the probability of tunneling effect by this formula. It is very simple. If we have, for example, such system, so if a particle need observe some fluctuation of energy for transition over the barrier, so we have it easily calculate some quantum mechanical and quantum mechanical skin layer, not fixation of the position. But if we have calculated such parameter, this area is very small. It is, in fact, we have the coefficient of transparency. It is the exponent power size of potential barrier, width of potential barrier, relation to such fluctuation. It's very great value, and also the coefficient transparency is very small, 10 power minus several thousand, for example. Okay, let's consider another point of view. It is not Heisenberg-Robertson, but Schrödinger-Robertson uncertainty relation. If we analyze the coherency between different agent states, we have absolutely different relation in general view. What is different? Is present such value. Here, R, it is a coefficient of correlation. The totally correlated state, R, is equal 1 units. So we have this value is approximately equal to 0. So we have the unlimited large dispersion fluctuation, and also increasing fluctuation, for example, both energy and both time, both pulse and both coordinate, so on. No, for example, for the case of pulse and coordinate, we have the following expression here. Or maybe using in this case, it's possible to introduce the effective Planck constant here, this value, and maybe introduce the effective coefficient of correlation efficiency, such. And for correlated states, coefficient of correlation efficiency, very great increase. Maybe value of such coefficient in realistic case, many thousand units. And of course, it leads to the very greatly increasing both fluctuation of energy and duration of such fluctuation, because and duration and magnitude of fluctuation is very important. For example, it is very simple illustration, uncorrelated state. It is usual such system mixed, in fact, so the state of any quantum, it is description not for system of particle, it's one particle, but the possibility of existence on the presence on different levels. So this fluctuation is absolutely uncorrelated, and also is, of course, if we have the general fluctuation in any moment pulse is very small. In correlated state, see, all this fluctuation is synchronized. And this fluctuation may be increasing by many thousand times and more. And of course, we have the possible generation giant fluctuation of pulse and giant fluctuation of energy. And all such process, creation of such fluctuation will exist for a very long time. It is very important. I discuss this. So let's consider the same process. If we have using not pulse Planck constant, carries well known, but effective Planck constant, we have using such additional square root. So of course, if we have totally correlated states, in case when the relation of size or width of the barrier to the such fluctuation quantum is very large, but the square root is equal to 0. So for totally correlated state, there is a full transparency of any potential barrier at any very low averaged energy. Very interesting. Okay. It is a very simple estimation for task efficiency. For example, let's consider the particles that situated in the potential well. For example, is the distance between two atoms. If we're using such relation, Schrödinger-Robertson, we have calculate the fluctuation of kinetic energy, such expression, and we have such expression. For uncorrelated state, for example, if we have the typical potential distance 1 angstrom, or half distance is 1 angstrom, so the fluctuation of energy is very small, very 50 milli-electron volts. But if we have the coefficient of correlation such value, it is a realistic value. Fluctuation of energy will be 25 kilo-electron volts. It is a very, very important factor. How we can create such system? There are different methods. Most simple method is the action on the potential well where a particle is situated for synchronization of wave functions on different levels. For example, it is possible by modulation of size of the potential well or depth of potential well. Most simple is size. Let's consider the various size of potential well is modulated by the periodical laws with frequency omega large. And this calculation, that system, you can increasing. It is fluctuation, increasing very fast, increasing fluctuation. And you can see that coefficient of correlation you can see at a more detailed such process described. And we have the coefficient correlation is very, very close to 1 unit. 0.999995 or 69 after 0. And also, we have calculated, it's calculated what the frequency is most optimal. What frequency most optimal modulated parameter of potential well for most effective realization of such coherent correlated state. Here is, for example, with the frequency of modulation 2 times less or more than the agent frequency, personal frequency oscillator. You can see, for example, it is a unit time. You can see the coefficient of correlation is such time in the unit omega 0 power minus 1. You can see 0.999999 so on. And also we calculated it is a time dependence of real coefficient transparency and averaged coefficient transparency. You can see averaged. You can see that increasing of in this case for G it is a ratio of relative amplitude of modulation potential well equal 10% only. And you can see in such time we have in fact full transparency of any potential barrier. On this figure you can see the investigated dependence of the formation of coherent correlated states from the different frequency of modulation. You can see the in fact very great coherent correlate format in 2 cases. When we have the frequency of modulation equal the agent frequency, It is on the frequency of main resonance, especially important when the frequency equal to such frequency, this one. It is a parametric resonance. It is dependent, but on the main resonance is very narrow, and this is very great, very wide equal to the coefficient of relative transformation of potential well. In any frequency, such process correlated and not formed. It is very important also. And also, next question, for example, what is the special selectivity nuclear reaction for such state? Very simple. Let's consider the system that is in such correlated state. For realization of nuclear reaction using such fluctuation of energy, because any nuclear reaction or any transition, because it is very interesting, what is the understanding of the process of tunneling? How can particles go through tunnel? By the fluctuation. He receives the fluctuation of energy in jumping over the barrier. But for realization process, necessary what? Particle go to the barrier, transition through barrier, and form a compound nuclear, and energy release. So such process, it is very long process, need be more short the duration of existence of such fluctuation. It is very limited process. For example, let's consider for the case of isotopic lithium. For example, lithium 7 plus proton. It is a format beryllium 8, and also in result we have 2 helium 4. Duration of such reaction in 10 power minus 20 seconds is very calculated. So it is a time during which we have conducted all process for nuclear fusion. For example, if for potential barrier we need energy, for example, 10 or from 10 to 100 kiloelectron volt, for such coefficient correlation, we have data correlation according to this, will be such value, approximately 10 power minus 18 seconds. But nuclear reaction duration, 10 minus 20. It's okay. We have the fluctuation that existed much more, by 10 times more long, that necessary for realization reaction.
4 minutes.
Let's consider reaction second, Li-6 plus proton. Approximately the same, but duration of such reactor, you can see 7 order more long. 7 order more long. So it is absolutely impossible using such fluctuation realize such reaction, because we have the same that we have money from the bank for some times, for this time, what? But we need return this energy in 10 power minus 4, no problem, okay. And it is very long time, so such process is absolutely impossible. So reaction is Li-6 plus proton is impossible, because for such reaction necessary fluctuation for very long duration and very large amplitude. It is impossible. So such reaction is absolutely impossible. The same variant, why is absent radioactive dot isotopes? The same reason. What is it dot radioactive isotope? It is an excited nuclear, compound nuclear that live for a long time. But he live to a long time, he cannot return energy fluctuation that necessary for formation of such state. So the same reason for example, a very strong suppression of gamma radiation. Gamma radiation is well-known radiation, electromagnetic radiation, but typical duration of gamma radiation is about 10 power minus 15, 10 power minus 14 seconds, well-known. But fluctuation necessary is the same problem. The same problem, we need, it is a time of existence radiation, and we need return energy in time by many order more long which has such value. So such channel is absolutely impossible. Very interesting models. Okay, let's go to the experiments at the beginning. What is according to our opinion, such reaction is take place during the process interaction of proton through lithium lattice system or the fragment of such lattice. For example, if the proton moving through the crystal lattice of lithium fragment, it is the same that we have the oscillator with modulated frequency.
2 minutes.
Case,
2
one
minutes.
frequency, this one, another one. So modulation is, it is easy to calculate. What is the parameter of such system necessary? It's very simple calculation. We can, for example, describe such modulation parameter using such value. It is not important calculation. And also the result. If the particle moving, what is the velocity? We know the period of structure. We know the agent frequency. It is calculate what is dependent from the velocity. And you can see it will very great peak, and the velocity, such velocity, that equivalent modulation in the system of particle in such periodical oscillator. So we have calculated, and easy to calculate, if we have to calculate this value. Just a moment, for example, lithium there, we have the value, it's about from 400 up to 600 electron volts. It's a totally very good, in very good relation to the experimental date, about 500 electron volts.
1 minute.
1 minute?
1 minute.
Oh, terrible. Okay, okay. So it is a, this result very good in this result calculation, very good experiment, both this value and also this. And also final part, okay. If we have only very short period of oscillation, we have the same effect, because in this process, it's not necessary in very long periodic structure, but also in one period, because in any non-stationary potential well, it is possible to calculate the Fourier component on the necessary frequency. And also we can see it is a dependence of the calculation of optimal particle velocity for one period, only one period. Only, we have only one, in fact, in the one elementary cell. And also, I will be, of course, what is the proposition? Now, we necessary using such system that can be, first of all, just a moment, because if we have using crystal, it is necessary very specific condition. First of all, generation of quasi-monochromatic one, directed one, and collimated beam. Necessary condition, necessary direction, so on. And the optimal direction of one. And what using the coronal discharge? Coronal discharge, it is if we have cylindrical cathode and very low voltage, for example, 5 electron volt, the main acceleration of particle will be immediately near surface of such very small cathode. For example, graphene nanotube has diameter about from 1 up to several microns. So main acceleration will be in layer about 10 microns only. It is a very great strength of electric field. And so we have what? We have such system. Such system, it is a nanotube, carbon nanotube, and gas, for example, deuterium gas, and voltage. And we have all electric field is immediately near surface. It will periodical motion, acceleration in one direction, another one. In each passing through the wall of graphene, we have formation of coherent correlated states and lead to the interaction of the same walls. So, no more one moment. So in this case, it is possible not any special orientation, monochromatization, no, only stable voltage and process cell orientation, cell monochromatization, cell any parameter lead to the possible reaction of carbon. Carbon is carbon 12. It is the main isotope of carbon nanotube. And deuteron in the formator in this reaction, nitrogen 14 and energy release 10 MeV. And also it is the main isotope. Also there is isotope carbon 13. It's concentration low, only 1% with proton such reaction. And also it's possible another. For example, silicon, it is silicon nanotube plus proton such reaction. So it is using such system, it is possible prompt the usual nanotube, it is possible automatically conduct self-controlling nuclear fusion with any external efforts. We have all the voltage and all the gas. Maximal pressure of this gas is about 1 atmosphere. 1 atmosphere, deuterium gas, and system of nanotubes and voltage. And periodically, for example, 1 time per minute, changing of polarity. Polarity because for self-cleaning nanotube of so on. No, I'm finished. Thank you so much. Thank you. Thank you for the attention. It is the conclusion, and also thank you.
So we have time for 1 or 2 questions for Vladimir. Lynn?
Yes, thank you for a wonderful talk. And I was wondering, the carbon nanotubes that you are using, are they multi-wall or single-wall?
It is not important. Typical nanotube made of single, but there is nanotube that consists from several, 2, 3 walls. It is not important.
Not important.
No important.
Okay.
In any case, it's absolutely free motion, but motion is periodic field of these lattice, one layer, lead to the generation of transverse giant fluctuation. So longitudinal energy only 500 electron volts, transverse fluctuation many kilo electron volts.
Thank you.
And one more, Conrad. This is the last question.
I wanted to ask you how you have calculated, this lifetime of beryllium-8 and beryllium-7, because you have so large different numbers for that. 10 to minus 13 compared to 10 to minus 20 second. How you have calculated, but
It
maybe
is
you can say
necessary for
10 to minus 13 second, how you have calculated it?
I don't know it is necessary for each kind of reaction. It is specific duration of reaction, duration of decay of compound nuclei. It is a specific calculation for any kind of
There is
reaction.
very simple. There is always the same for all the nuclei. It is characteristic nuclear lifetime. So it is 10 to minus 20, 10 to minus 21, something like this. Okay, so there is
Yes.
no difference. You shouldn't have any difference.
Yes, but you can see for lithium-7, lithium-6, from usual point of view, it is absolutely similar isotopes. But one direction of
Yeah, this is the
10
question.
minus 13, it's 10 plus 20.
Yeah, this is the question. How you have calculated it? Because there is something.
No,
what
it is not my calculation. It is a table dating the
No, there is no
base.
table. There is this number 10 to minus 13. It is probably for first excited state of lithium-7 or beryllium-7. There is a lifetime of that. There is not compound nucleus.
Maybe,
Okay, there is one
maybe
point.
it is each nuclear necessary special analysis.
No, so it is a completely different thing.
I don't conduct such analysis. I'm using the standard expression from the literature.
No, there's okay. There's another question to the experiment you have. There is published.
Yes, yes. It is not my experiment. This experiment was conducted in the United States.
No,
And they
I haven't seen this. Where
Yes, yes,
this
it's
published?
well-known published. It is a description to the patent. There is patent.
There is okay. There is
Patent about 50 pages with the more detailed
Okay,
date
okay.
of all experiments.
There is Lipinski.
Lipinski, absolutely
Okay, I know.
correct.
So
Yes,
there
yes,
is
yes, Lipinski.
probably they have measured some noise. Not
Yes.
correctly the directions.
Yeah.
Okay. This I have no questions. Thank you.
Yes, okay, thank you.
Thank you, Dr. Vysotskii.
Thank you.